Our group will be presenting about the shipping rates of Shopee for West Malaysia. Our group member consists of Siti Nur Aina Wahida, Amira Fatiah, Aina Kaisara and one Muslim Reza. As we know, shipping rates are considered common when it comes to online shopping. Shipping rates are what sellers charge their customer in addition to the cost of the product that they order. We take the data from Shopee supported logistics and we only take 10 data from the database. We want to analyze the relationship between chargeable weight and doorstep delivery fee within West Malaysia. This is the data for the chargeable weight and doorstep delivery within West Malaysia.
First, we define the data with 10 data points. W is weight and FW is shipping rates. The software generated a graph with the data that we define, W on x-axis and FW on y-axis with circle symbols in dark green. The software generated matrix A1 and in order to construct a quadratic model, the software generated matrix A. The software formed an augmented matrix by combining matrix A and data of FW. Then it applied reduced row echelon form to find the least square solution.
Assalamualaikum and hi. So right now I will continue Aina Kaisara presentation and talk about the codings that we use in our mapper software, which is to find the best fit of the quadratic curve. So in the 8th step, we want to find the transpose of the matrix of A. So the coding is AT equal to transpose of the matrix of A, and we get the answer in the blue color. And after that, we multiply the transpose of the matrix of A with the original matrix of A, and we get another answer for that equation. And after that, we want to find the determinant of A equal to determinant of A transpose multiplied with the matrix of A, and we get the answer which is 435,600. And we multiply the transpose of A matrix with the matrix of B equal to A transpose multiplied with FW, and we get the answer which is 86.8000 553.8680, and the last one is 4197.0687. And we want to let a new matrix which is we let with M equal to A transpose A transpose B, and we get the answer. And we want to reduce the matrix until with the RRAF, which is reduced row echelon form, and we get the final answer. And we can see here for the x to the power of 0, we get 4.1584. For the x to the power of 1, 0.6533, and for x squared, we get 0.02386. So next, we want to show the best fit of the quadratic curve. As you all know, the general equation for the quadratic curve is 8x squared plus bx plus c. So we put the value that we get earlier in this equation. So y equal to 4.1585 plus 0.6534x plus 0.02386 a squared. So we want to show this formula into a graph. So we code it b equal to plot yx from 1 to 10 and display d and b. So we get this graph. So the line touch almost of the point, but 2 points doesn't touch very well. So last but not least, from the answer that we get, which is 4.1585, 0.6534 and 0.02386, we want to find the area of the magnitude of the vector. So the coding that we use is ERR equal to FW minus with the matrix of A multiplied with the answer. So we can get the 10 points of the error magnitude of the vector, and we want to find the magnitude of the error, which is equal to norm ERR2, which is L2 norm, that we also known as Euclidean norm. So the final answer for the magnitude of the error is 0.2413.
For the manual mathematical solutions, W will be the chargeable weight, and FW will be the doorstep delivery fee within West Malaysia. For quadratic equation, the formula is y equal to a plus bx plus cx squared. Therefore, we will turn each data we have into quadratic equations. Transform the system quadratic into the metric form, which is ax equal to b. We will be solving for w equal to matrix ABC. We will use the RREF, which is reduced row echelon form. We make the first column into a leading one. Continue on the next slide. We will also turn the second column into a leading one, which left us with the third column, and we will reduce it until it cannot be reduced. As we can see on the fifth row, there is a false statement. Therefore, the system is inconsistent. Because the system is inconsistent, we will use the normal system, which is A transpose AX equal to A transpose B, which I now will be explaining.
Hi, my name is Saitin Anawahida. So, since the system is inconsistent, we need to use normal system method. So, to find the normal system, the formula is A transpose AX equal to A transpose B. So, to find the left hand side A transpose AX, this is what we got. Next, we need to find the determinant for A transpose A, which is we got 435,600.1655, which is not equal to 0. This means the system has a unique solution. For the right hand side, which is A transpose B, we got this. So, to find the value of A, B, and C, we need to compare both of them. This is what we got. C equal to 0.02386. Meanwhile, B is equal to 0.6535 and A is 4.1583. Then we can find the best fit quadratic equation, which is FWA plus BW plus CW squared. So, this is what we got. After that, we can find the least square error vector. This is what we got. Next, and the final one is we need to find the magnitude of the error vector. We will find 0.2413.
In conclusion, from the quadratic model above, the following error magnitude in the approximation is obtained.